My name is Navawanga Afwa here too, and I'm going to go through the introduction to machine learning. Machine learning, by definition, is a field of study that gives computers the ability to learn without being explicitly programmed. So, to kind of break down the definition, it means that the computers are going to work without instructions from humans, meaning for a program to work, there are no instructions required from humans. For example, an example I can give on machine learning, it's online shopping, whereby online shopping can go to a new site and do some orders today. If you go again tomorrow, the same site, it will show suggestions depending on what you searched for yesterday, something like that. So that's the concept of machine learning. For the applications, just like I've said, online shopping, it can be applied in image and speech recognition. Look at healthcare, whereby you will not first program the machine to show you the diagnosis, like it will automatically show you when it's being programmed. For the types of machine learning, we have supervised and unsupervised learning. For supervised learning, okay, basically there is supervision, meaning we train the machine using labeled data. Labeled data means that the input is known with the corresponding output. So the input data, remember, it's already known with the correct output. So providing this input data, as we go ahead and provide the input data as well as the output data to the machine learning module. So supervised machine learning has still two subsets, that's classification and regression. But for classification, this this machine learning algorithm, it classifies between two occurrences. There are basically two occurrences. It's either yes or no, or maybe in humans it can be female or male, true or false, something like that. But for regression, it basically involves predictions. To give an example, okay, predictions for occurrences which are continuous. To give an example of temperature. Temperature, you can't just decide that the temperature is going to be 20, something like that. It goes ahead to continue changing. That's basically where the regression algorithm can be applied. Look at temperature, maybe salary, the price, the market trends, weather forecasting, where the occurrences like are continuous. But for classification, there are basically two occurrences. Look at an example. If we are determining if an email is spam or not, maybe if something will be harmful or not, there are basically two occurrences. So basically, supervised machine learning, it involves supervision, like meaning the machine is trained on what it's going to do. Yeah. So we have what you call a data set. A data set is something that's human refined that does not have any noise. So in simple terms, a data set is simply a collection of data. A collection of data. Just like you see in this example, you can see this data was collected depending on the position. Position, someone is a developer. Experience, 0. Maybe skill, 1. Country, USA. City, New York. Salary, this. This is a data set, meaning data was collected. So it's simply a collection of data. So we have what you call training. Just like you hear training. Training is a learning process. Like someone does not know, so he's going to go through training. Maybe someone has applied for a job, but then has to go through training. Training is learning process. You get to know maybe of what you get to know what goes through. Like, for example, you've applied for a job. You go through training depending on what you've applied for. After training, what do we expect? Training includes solving questions, comparing with correct answers, self-assessment. Yeah, like you're done training, obviously expect questions like comparisons, then self-assessment on what you've trained. Yeah, so that's basically the training concept. Then by definition, supervised machine learning is a type of machine learning which requires human labeled data. By mere seeing labeled data, meaning input is known plus the corresponding output, which provides the necessary supervision during machine learning algorithm. You get, since the input is provided and the output, it provides the necessary supervision. For the types, regression and classification, I already talked about regression, whereby it's continuous. For classification, two occurrences, whether an email is spam or not, or whether something is harmful or not. It's categorical in nature for classification. That's why it's either yes or no, true or false. But for regression, it's continuous. That's why you see it's applied in occurrences like maybe weather forecasting, temperature, the price, the salary, look at the market trends. If I'm talking about regression by definition, it's a type of supervised learning technique used to model and analyze relationship between dependent and independent. For dependent is the target. This is the variable. That's this slide. For dependent is the variable which we are trying to predict. Yeah, like we want to know the temperature, want to see the house price, right? But for the independent variable, these are what we use to predict, like the dependent variable, the target. Remember, for example, we want to know the house price. We can use the number of rooms, right? Yeah. So for classification, I talked about it already. Yeah. Then you have k nearest neighbors. So for k nearest neighbors, this specifically classifies new data points based on the majority class among its k nearest neighbors in the training data set. Okay, to talk about these k nearest neighbors, look about an instance where we are given two categories. Maybe category A. Remember, we want to know why do we use this KNN. We're given two categories, category A and category B, and maybe some other point X. So this data point, we want to know where this data point X, where is it going to lie? In either category A or category B. That's where we go ahead and pull the KNN to come. It can help us determine where this point is going to lie, whether in category A or category B. So for use cases, can be used in text mining, agriculture, finance. Then clustering. What I can say about clustering, just like you hear, cluster is simply a group. So clustering, it groups together features that exhibit the same X-ticks. If at all, yeah, like bringing together features that have the same X-ticks. An example is the different Netflix users that can have similar preferences. It can be hierarchical. It can see a subset of clustering, hierarchical clustering. Like it clusters different groups, cluster into different groups. Or yeah, let me continue to anomaly detection. Anomaly detection, it simply involves detecting an unusual occurrence of the data instance in the data set. Remember, like the detection is like the occurrence, what we expect is unusual. So detecting unusual occurrence of data set, or unusual occurrence of the data instance in the data set is what we call anomaly detection. Then for a model, talk about a model. A model specifically is just a representation of maybe a process. Yeah, it's a mathematical representation of a process or relationship that is trained on the data predictions or make decisions. Like it's a mathematical representation of a system. Of a system or process that is trained on the data to make predictions. So what we call a math or stat model is described relationship between variables. Yeah, so which kind of variables? What called deterministic and probabilistic. For deterministic, these models assume that the relationship between inputs and output is fixed. Like we know, like it can't change, it's fixed. So we can automatically, okay, it doesn't involve any randomness. Like we don't expect uncertainties, like it's fixed. Yeah, but for the probability, there's no like probability, like there are chances of everything happening. So we expect randomness here and uncertainty. So the two components here, or the types of probabilistic models, we have regression models and correlation models. So regression models. Regression models, these are require a relationship between one dependent variable and explanatory variable. This, okay, specifically they are used for prediction and estimation. Decision trees, these are tree-like mode structures where a node represents a feature, then a branch, a decision, and then the leaves, they are the outcomes. Maybe some of its advantages, it's interpretable because, yeah, we know that like a node, it represents a feature, a branch, decision, then a leaf, outcome.
Hello, my name is Dumba Jonah, and I'm here to explain machine learning. Uh, so far as my colleague explained before, we have the types of models, and so far, let me first do a recap about machine learning. So this is just a subset of artificial intelligence that focuses on developing algorithms that enable computers to learn from the decisions and also make decisions based on the data. And among the types have supervised learning and unsupervised. So supervised learning, so here are the algorithms learn from labeled data. Labeled data that we humans label, and we give it a direction where to uh, gather up the information, make a conclusion. So where the input data or features is paired with the correct output. So, and how it works, the model predicts outputs based on the input data and adjusts its parameters to minimize errors using the provided labels. So let's say we have the prices, the cost. So it uses those labels so that it can predict the data that you want according. So the logic behind is a programmed, but the results, it gives you the results because it uses the label data you give it. So among the key applications, we have the regression and classifications. So regression, predicting continuous values such as house prices, stock prices, like I explained before. So the classification, assigning data into uh, categories. So for example, you have spam detection, image recognition, and going further to unsupervised learning. The algorithm learns patterns or features from unlabeled data without specific output labels. So this one basically uses patterns. Uh, so how it works, the model identifies hidden patterns, clusters or associations in the data. So it learns according to how the data has been flowing, the patterns that it observes. So, and among the key applications, we have clustering, dimensionality reduction, association, rule learning, and many others. So, clustering, grouping similar data points. For example, we have customer segmentations, and for dimensionality reduction, here the simplifying of data while retaining important information. For example, you have the PCA for visualization. So, and for association rule learning, finding relationships in data, like for example, have the market basket analysis, many others. So going further, the types of models, you have the deterministic models, and probabilistic models, parametric models, and parametric models. So, starting with the deterministic models, so these are the models that provide the same output for a given input uh, every time. They do not account for uncertainty in predictions. And among its characteristics, the output is fully determined by the input and model parameters. These models are often simpler and computationally efficient. So when we go to the probabilistic models that predict probabilities, sometimes distributions of possible outcomes, incorporating uncertainty in their predictions. So among its characteristics, we have so here the outputs are not fixed or even may vary based on the model's confidence. So this is very useful in the world applications, like in the real world applications, where uncertainty is critical. Like for example, like medical analysis in hospitals. And going further to parametric models that make assumptions about the underlying data distributions and have a fixed number of parameters, regardless of the dataset size. So the characteristics are the fixed parameters, faster training, and risk. So the fixed parameters, the model specifies, like simplifies learning by summarizing data into a few parameters. So here, whereby it is easier to break down the data and simplify it further. So also this model it trains faster. It requires less data and computational resources. Thereby, you won't have to give it a lot of data or specify what or what. It trains faster to observe. So, and also may underperform its if assumptions are wrong. So if you give it like less data, maybe it makes a wrong assumption according to the data that it's been given. So it literally underperforms. So going further to non-parametric models, models that make minimal or no assumptions about the underlying data distribution and the number of parameters grow with the data. So among these characteristics, we have flexibility and data dependence. So this model can adapt to more flex data patterns. It can also perform much better with larger data sets. And among the applications of machine learning, so let's just list a few. So we have natural learning process, NLP, language translation, sentiment analysis, image recognition, computer vision, healthcare, like in hospitals, facial recognition, and many others like in finance, fraud detection, algorithm trading. Moving next to KNN, which is defined as the k-nearest neighbors. So this algorithm is simple, intuitive, non-parametric, and widely used supervised learning algorithm for both classification and regression tasks. KNN works by finding the k-nearest data points in the future space to acquire like a query point and making predictions based on the majority or average of the those k neighbors. So, going further to the iris dataset. So, this dataset contains information about like 150 iris flowers for 3 species. So here we have Setosa, versicolor, virginica. So each instance has 4 features. I have the sepal length, the sepal width, the petal length, and the petal width. And sometimes when they are questioning, they might bring sepal height or petal height, but those are not inclusive. Those ones they are wrong features. So when you go to the decision tree, so this is a supervised machine learning algorithm used for classification and regression tasks. It splits data into subsets based on feature values, creating a tree-like structure where each node represents a decision based on a feature, and each leaf node represents an outcome. And going further to ensemble learning is a technique that combines multiple models and by improved accuracy. Some methods often improve accuracy, reduce overfitting, and enhance generalization. So why do we use ensemble learning? This one, it improves mostly accuracy, reduces overfitting, and it also increases robustness. So among the types, we have bugging and boosting. So training multiple models on different model subsets of data, This one also combines predictions using average for regression or majority voting. And secondly, we have boosting. So this one trains the models sequentially, where each model corrects the errors of the previous one. It also combines the prediction by giving higher weight to the more accurate models. And lastly, just going to describe a bit of the random forest. So the random forest is a popular and powerful ensemble learning algorithm used for both classification and regression tasks. So this one builds multiple decision trees during the training and combines their outputs to make like more accurate and robust predictions.